Hello, everyone. My name is Leonardo Fiorini. I am the technical director and one of the owners of Inspek Engineering. First, I would like to thank Energodiagnostica for the invitation to participate in this conference. This is very important for us to be present every time we can. And also thank Sergey for all the arrangements and to make it happen. I will share my screen first. And during the presentation, the slides, I will turn off my video so that it doesn't get in the way of the slides. So the main focus for us in Brazil is pipeline integrity. We are very focused on buried pipelines. So we do non-contact MMM applications. At the moment, as I understand, we have the largest non-contact buried pipeline inspection in the world, the largest contract in the world. And the main issue of our presentation today is application of the MMM to subsea pipelines. So this is the main focus. If you need to contact me in the future, you have my email below. In the end, I'll show you also my email and our telephones that you can reach us through. Okay, so we start with the index. I'll talk a little bit about the services that we offer in Brazil, the markets we attend, the historic of the technology in Brazil through us, and the inspection of offshore pipelines using MMM. The services that we provide. Like I told you, the main focus that we have so far is onshore pipelines inspection. So we're talking about aerial, but mostly buried pipelines. We do special services with UAVs. So we're talking about drones. So topography, imagining, and digital reconstruction. So we can do, for example, high quality topography on hills where there's a pipeline or not, it doesn't matter. So we can do this with drones. We do underwater inspection and maintenance. We have partners for these kinds of applications. We do location and georeferencing of buried pipelines. This is also a part of MMM. So once we get to a contract that we're going to provide MMM inspection, the first step is locating the pipeline and georeferencing. So we have to make sure that we're walking right on top of the pipeline, and then we have precise GPS information. This is very important in Brazil. We can also provide services for companies that want to be established in Brazil. So we can work on the legal terms and mostly for engineering companies. This is very restricted and very bureaucratic in Brazil, so we can help with you with whatever you need in these matters. The markets that we attend, so first of all, refining for sure, fuel transportation, petrochemical, sanitation, industrial, mining, and many others. So of course, the main focus at start was Petrobras, so the largest oil company in Brazil, Comgas, which is the largest gas distribution company in Brazil. We have a big contract with them. Braskem, the largest petrochemical plant, but also other markets that we started to provide services once we get these large contracts running. So for example, water is very cheap in Brazil. It was very hard to start providing services for water, not because of the technology or the technical part, but because of the market. We needed to get it running and getting it as a low cost as possible to make sure that it happened. We're not only providing services in Brazil, we did 3 services in Saudi Arabia. The companies were Petrochemia, Saudi Aramco, and also SWCC, Saline Water Conversion Corporation. So we have other applications, not only in Brazil. Here you have also Rio Galeão. Rio Galeão is the airport in Rio. So we did a service to locate and georeference pipelines for them. Okay. And of course, if we're talking about the next part of the presentation, once we're talking about subsea pipelines, our main customer for sure will be Petrobras. There are other operators in Brazil, but Petrobras will surely be the main goal. A little bit about the historic. So this, for example, this map shows in red the lines that we have inspected last year alone. So until now, we did more than 1,200 kilometers of buried pipeline inspection. And the applications are all over the place. So cities, terminals, petrochemical plants, industries, and many others. Of course, there's a limitation in terms of the interferences, but we are doing services in streets, in avenues, in the middle of the forest, in plants. It doesn't matter. And now running to the part that we are focused on at the moment. This picture shows a little bit about the pipelines that we're trying to inspect. So the idea is that we create a special sensor, sensor, that would run on top of these pipelines. So you can see that they are not only vertical or horizontal, they do some kinds of movements. And I'll show you a little bit in the next slides, but we're talking about up to 3,000 meters underwater. So this is very long. So one inspection alone could be up to 5 kilometers long because of this movement of the pipelines. So the motivation of this application, why do we want to do this? Brazil is the world leader in deep waters oil exploration. So if you see the graph on the left, you'll see that Brazil has the largest production, and also it is increasing over time. So this is very important. This is a very, very big market in Brazil. Of course, we're talking about Brazil, but anything that we develop in Brazil with energodiagnostica can be applied anywhere in the world. So this can be very interesting for every one of you. The region known as pre-salt can be up to 3,000 meters deep underwater. Pre-salt is there's a big layer of salt, and the reservoir is right underneath it. So you imagine you have 3,000 meters of water, and then you have to dig through a very specific layer of salt. There's a lot of requirements for this drilling. This is not simple at all. And after it, you have the reservoir. So this is very important. According to Petrobras, the pre-salt production grown for 41,000 BPD in 2014 to 1,500,000 BPD in 2018 from 77 wells. There is also another very important information that these wells are not close to the shore. So they can be more than 200 kilometers away from the shore. So an operator, for example, needs to get a helicopter, had a long flight up to the platform, and then provide the service. Sorry. Continue about the motivation. Petrobras has a specific project for diverless operation. So all services that were they used to do with divers, so inspection, maintenance, or whatever, they want to do it with robots or whatever other technology possible. So the motivation is to avoid at any costs and mostly maintain safety, because this is a very dangerous area. So whenever you can avoid diver, this is very important. CO2 stress corrosion cracking is also a very big problem. So this is a very good opportunity for MMM. So you can see pictures below where there is a rupture in the steel wires. You will also see that these are not common pipelines. This is not just a tube. This is a tube inside a tube with several layers of plastics, and this armor, these wires that are that run across the pipeline. So this is a very interesting kind of construction. the complexity, like I was talking about. So you have an inside carcass where the product flows, and then you have several different layers, including these tensile armors layers. So this is where the problems are happening. So our main focus is to actually inspect the wires. So this is the main opportunity. Remember that when we are talking about a pipeline that is above ground or buried, it's mostly fixed, right? It's stopping in the same position. Once it is on the shore, on the ocean, there's a movement. So it's a complete different kind of stress that it runs through this kind of pipeline. We did last year a test for a customer. We cannot mention the name of the customer or show the pictures, but I can show you a little bit about the results that we had. The idea of this test is doing it on the lab. So these pipelines were on production, they were on use. They took it off of the ocean, cut segments, and we did inspection inside the lab. So segments of pipelines that ran a lifelong experience of production. So this first segment we did on 12 o'clock, so right on top of it, using non-contact first. The gray parts that you see on the graph are before and after the pipeline. So we made sure that we didn't have interference of the borders of the part. Afterwards, we did contact inspection in the same segment, also 12 o'clock. So you can see the difference in detailing from the contact inspection, okay? So here you can see the movements, but contact inspection, the results were much, much better. Another segment, so once again, before and after, it was gray. And then the contact inspection. So this is a much shorter part. And you can see this, this formation in the end of the graph, this very complex formation. We assume that this is due to the strength that is running through these wires when they're trying to get out of shape. So you can imagine if you have a 1 kilometer long pipeline, the armor is very tight together. Once you cut where it's very close to the edge, to the border of the part, it starts to trying to get out of shape. So this is what we think happened in this point. One very important information is that the customer is going to compare all this information with several other technologies. So this is just the beginning of using MMM to this application. The idea is that we combine several different technologies in terms of analysis to make sure that we understand what these results are. So they are very important. We can definitely see the damage, but having a comparison with other technologies is very important. And we were the first technologies to be applied in these pipelines. Another segment that we did, now a little longer, 9.5 meters long, more or less. Once again, non-contact on top and contact on the bottom. And you can see the contact information, it's much more precise. And you can see this, this kind of shape of the curve. Once again, we think that this is due to the wires trying to deform again because of the cut, okay? On the right, once again, the same segment, but on 9 o'clock. And you can see that it matches almost perfectly from 12 o'clock to 9 o'clock. Talking a little bit about the application itself, the complexity. This video that I'm going to show you now is a project called Series. They have already worked with Petrobras with several tests. They did several tests. And the idea is that we can use this kind of transportation for the MMM sensors. This is just one possibility. The other possibility is having a small ROV outside of the pipeline carrying sensors, for example. So one idea of how it can work. Real case scenario, trying to inspect. Yeah, of course. And remember that this can run up to 3,000 meters below the water, for example. They had already experienced very close to these applications. And of course, we're talking about a completely remote operation. So all operators are on top, on the ship, or preferably on the platform, okay? And talking about, again, about the graphs that we have shown, we think, of course, we have to discuss this with Energodiagnostica, but we think that the sensor should be a mixture in terms of the sensibility of the contact inspection, but with a kind of non-contact application, because you can imagine here you're watching a very straight pipe, but you have segments where they are connected together, two segments of pipeline. So it's not possible to run direct contact to the pipeline as we think. So challenges. This is a completely new kind of system to inspect it. So like we're talking, we're starting to develop the analysis. New sensors and the files collection block are completely different. We need to discuss this also. You can imagine the size of the files. For someone that is used to do pipeline inspection, imagine trying to do inspection with several sensors for 5 kilometers long. This is very long file. Of course, we need a high pressure casing for the sensors and the block. So imagine the pressure that you need to hold for this kind of depth. And of course, the small ROV to move the sensors. So these are the main challenges for this operation. The development. So we think that this should be incremental in terms of the depth. So for example, if we start with an operation for up to 50 meters, we have already a big market to apply. You can imagine we're talking about subsea, but this can go through dams, rivers, lakes. You will have application for this kind of application anywhere in the world. For sure in Russia, in Asia, in Europe, you have a lot of applications. So our idea is to start to grow, to go deeper for each step of the way. So 50 meters, 150 meters, 500 meters, 1,500 meters deep, and then plus 1,500 meters deep. Once you get to 1,500 meters deep or more, we're talking about the whole application. So the project status. First, we have the demand already defined by the customer. This already happens. They want to contract the service. We are not ready yet for it. We just did inspection tests in lab. So we're working with them to make sure that results are very good, comparing with other technologies. We need to acquire the MMM equipment. So we're talking to Energodiagnostica for the development and the acquisition. The casing development, the casing design, to make sure that it holds together the pressure. Inspection in local, so doing actual inspection on pipelines on the shore, on application. And the real case service. So this is the sequence that we want to make sure it happens to make the service possible, okay? The next step, we are searching for investment partners to develop the final equipment setup and proceed with tests. So this is not a very simple project. We know the technology. We know that there are vehicles, there are ROVs ready, but to make it all together and provide the very good analysis is something that we have to work with. It's not easy. Let me put my video again. So if you need to contact us somehow, you have our emails, the telephones, and we will be very happy to talk to you about this project or even the services that we are providing for buried pipelines. Anytime you want, we are ready to talk to you. Okay? Thank you very much. Spasiba.